Alright, y'all. Today we are going to talk about projectile motion problems, or basically quadratic word problems. And these are scenarios like following the path of something. So, like a ball thrown upward from the top of a building, or you and a friend hiking in the mountains. And it's going to ask you questions like, what was your starting or your initial height? And we know that initial means we're talking about the y-intercept. Okay, it might ask us, how many seconds did it take us to reach the maximum height? What was the maximum height? How high was the ball after so many seconds? And then when does it hit the ground? So I want to kind of show you this on a graph. So if this were our ball problem, so let's say we've got a baseball that we're throwing. And it says we're throwing it off of a building. So we're going to start at x equals 0, right? Because if we're talking about a ball, time can't be negative. So I'm actually going to block out the left side of this graph because we can't have negative time there, okay? Let's see. It might also, if it asks us like how high was it when we started, that's just asking us what our y-intercept was. If it asks us for the maximum height, that's going to be our vertex, right? If we follow the path of this ball, it is at its highest point at that vertex. It might say at what time does it reach its max height. Well, if we follow that down, we're going to find the time. We're going to see where the max height and the time overlap. That's going to be our axis of symmetry. And then it could also ask us when it hits the ground. So that's going to be whenever our height equals 0, or when y equals 0, which happens at our x-intercept, which we can find by finding our solutions or our zeros or our roots. So let's look through a couple of examples here. So what I'm going to do first is just type this equation into Desmos, and then we're going to look for all of those key features on our graph. So my equation for this one is negative 16 t squared, and I'm just going to replace that with an x for simplicity. Okay, so now I'm going to have to zoom in a little bit. I've got this quadratic, okay. I have to zoom out a little bit. It's kind of narrow and skinny, okay, but it asks us what is our initial height of the ball. So for the initial height, we want where time is 0, right? So that means where our x is 0, or where we cross the y-axis. So that happens at when x is 0. So the initial height is 180 feet. Then it says, how many seconds did it take the ball to reach its maximum height? Well, if I click on the maximum, the top of that graph, the top of its path, I'm going to get those numbers right there. So let me pop that up again. And if we're talking about seconds, that means we want time, which is the x value. So that's going to be 0.938. Okay, so that's the axis of symmetry, or the x of the vertex. Then it says, what was the maximum or minimum height? So that's going to be our y is our height. So that's going to be our y value of that maximum. So that's going to be 194.063 feet. And that last one was seconds. Sorry, I forgot to put units. Then it says, how high in the air is the ball after 2 seconds? So we are looking for where we're going to plug in for x. So we want to find wherever x equals 2. So there's a couple ways to do that. You can scroll around on your graph, and you can see that it's at about 176. But it is kind of hard to find that. So if you are getting frustrated with scrolling, you can also type in x equals 2 and just kind of see where those two lines cross. So you can kind of see a purple line and a green line there, and they cross where x equals 176. So it's at 176 feet. And then it says, when will the ball hit the ground? So that's going to be our solution, or our 0. So you could solve that by hand if you wanted to factor it. Or if you're using Desmos, we can just see where it hits the x-axis. So if you notice here, we've got 2 of those. One is at negative 2.5 seconds and 4.42 seconds. but we're not going to worry about the negative time because we don't have negative time. So we are going to just use our positive one. All right, let's do one more example of this. So you and a friend are hiking in the mountains. You want to climb a ledge that is 20 feet above you. The height of the grappling hook you throw is given by the function. So let's type that in. Again, I'm going to just use x's and y's just to make it a little easier. So we're going to do 10x squared plus 20x plus 5. And we're going to zoom out to find that graph there. And it says, what's the initial height of the hook? So the initial height, again, we're looking for that y-intercept. Okay, remember that word initial is going to mean y-intercept. So we cross the y-axis at 0, 5. So the initial height is 5. Remember, if it's talking height, that means y. If it's talking time, that means x. So 5 feet. How many seconds did it take the hook to reach its maximum height? Well, let's look at our maximum height. That was 1:15, and it says seconds, so we're looking for the x value, so that's 1 second. What's the maximum height? Well, I've already got that pulled up, so that's 1:15, and I'm talking height, so that's going to be my y, so it's going to be 15 feet. How high in the air is the hook after half a second? So 2 ways to do this. Again, I can scroll on my graph and just look for where x is 0.5, which we can see is about 12.5. But if you're having trouble scrolling, you can also type in x equals 0.5 and see where those lines cross. So it's at 0.5 and 12.5. So after half a second, we're at 12.5 feet. And then it says, when will it hit the ground? So that's where we are looking for where we're crossing the x-axis, because think of the x-axis as the ground. So there's 2 of those, but we're going to throw out our negative value because we don't have negative time. So this will be 2.225 seconds. We'll do a couple more examples in the next video, so check